Hi, my name is Aarush Khanna and this is my Raspberry Pi security camera project for CNIT 176. So, the goal of this project was to build a fully functional video surveillance system that can stream video from a Raspberry Pi, record continuously, as well as automatically upload these recordings to a cloud storage. Now, in this presentation, I'm going to walk you through the business case, the Raspberry Pi architecture I used, the procedures I followed, troubleshooting that I did, and also a small demonstration of the final working system. So before we begin, I'm going to show you the three basic components I used to complete this project. Those were a Raspberry Pi, an SD card, as well as a USB camera. A security camera with off-device storage is a real-world system used in homes, businesses, and IoT deployments. My motivation for this project was to build a low-cost, reliable camera setup that stores video safely in the cloud so recordings are not lost if the Raspberry Pi fails. Now, this project also helped me learn system automation, video processing, and cloud integration, skills which are directly related to the CNIT program. The Raspberry Pi 5 uses a quad-core ARM Cortex A76 CPU running at 2.4 GHz. This processor handles tasks like capturing video frames, running FFmpeg for encoding, and managing simultaneous system services. The modern ARM V8 architecture supports efficient media processing, which is perfect for a camera system. My Pi has 4 GB of RAM. This memory is essential for buffering video, running the MJPG streamer service, and handling local file operations while simultaneously processing uploads. Video tasks are memory intensive, so this architecture ensures smooth performance. The system runs on a 64 GB micro SD card using the extension 4 file system. I created a dedicated folder called Recordings where 1-minute video segments are saved. To prevent storage overflow, Rclone automatically moves completed videos to Google Drive. The webcam connects via USB and is detected by Linux as Video 0. The Pi's USB controller uses the USB video class driver, which allows compatible webcams to stream raw MJPEG video to applications like FFmpeg and MJPG Streamer. The Raspberry Pi connects over Wi-Fi. Networking is essential because recordings are uploaded to Google Drive through Rclone. My systemd services wait for networkonline.target to ensure the upload service works even after a reboot. I started by installing MJPG Streamer to create a real-time video stream. The stream is available on port 8081. This allowed me to verify the webcam was working perfectly and correctly and producing a stable video feed. Now over here you can see a demo of the webcam working on the website link sample that I provided before, and you can see me on the video. It seems to be lagging a little bit because the screen recording feature was too heavy for the Pi to handle, but that is what was the output. Next, I used FFmpeg to continuously save the live stream as MP4 files. I configured it to split the recording into 60-second clips. I then created a systemd service called camera-record.service, so recording begins automatically at boot. In this folder, you can see there are MP4 files being saved. These are the files being saved by the camera record service. To meet the cloud storage requirement, I used Rclone to connect the Raspberry Pi to my Google Drive. I created a folder called Security Camera. Then I wrote a script that detects new recordings using iNotify-Wait and uploads them to the drive and deletes the local copy. In this demo video, you can see the process I just explained happening. The script I created is uploading the files, MP4 files, 1-minute MP4 files, to the Google Drive. So now it's time to see the live demo of the project I've been working on for the past 4 weeks. Yay! Okay, so this is a live demo of the project. As you can see, there's multiple windows open, so I'll explain to you what each of them are about. The top left window is the stream, my stream running on port 8081, which we looked at previously. As you can see, that is the live stream being recorded by my camera, security camera. And on the bottom left corner of the window, you can see my Google Drive. Those files are from my previous a test for my security camera. And on the top right hand side, you can see my recordings folder on my local computer. So this is like the basic setup of my Raspberry Pi security camera, and I used a screen recorder to record everything happening. That's why you can see a VLC window open. But as you can see over here, are my recordings are being saved in the recordings folder. On the top right corner, you can see two recordings right now, 000 and 001. This is on each of them are 1 minute long recordings. Now these are going to be slowly uploaded to the Google Drive. As you can see, yes, see, as you can see, the file just appeared on the Google Drive, and that is my upload service file working, and you can see it happening in real time. And as soon as the second recording gets completed to like a 1 minute file, it's going to be uploaded to the Google Drive too. So that is basically how the whole project works and how the whole security camera works. And for you to be able to know if the whole project of the security camera is working perfectly, there are two lines you can type into the terminal. As you can see what I highlighted, one says sudo system ctl status camera dash record. That's the record service which I created, and the output says that it is active and running. This means that the file has started. And the same thing I can do for my sudo system ctl camera dash upload, which is also active and running at this point. And this would tell me if it is or it isn't. Okay, so it's time to go on to the troubleshooting part. So I spent a significant amount of time troubleshooting this project because several systems I initially relied on simply didn't work as expected. Now I'm going to walk through the key issues I faced and how I figured out the solutions. The first major problem appeared right at the start: Motion Eye. This was part of the approved project list guide, so I assumed it would be straightforward. But every installation method failed. App installed failed due to invalid HTTPS certificates, pip install was blocked due to Python version mismatches, and the official Docker images no longer exist. At first, I thought I had a networking problem or that my Pi was misconfigured. To investigate, I ran apt get update manually and saw errors about the certificate being untrusted. I checked the MotionEye project page and discovered it was actually abandoned in 2022. So the issue wasn't my system. The software itself was no longer installable. This led me to switch to a modern alternative using MJPG Streamer and FFmpeg. Now, after getting the live stream working, the next obstacle was creating an automated recording service with systemd. When I tried to start my service, systemd threw a bad unit file setting error. The logs weren't clear at first, so I used my systemd analyze verify to pinpoint the exact line. It turned out that the problem was the %03d file name pattern used by FFmpeg. Systemd treats percent symbols as variable placeholders, so it was interpreting %03d as a systemd directive. Once I learned that, the fix was to escape the percent sign as %03d. This wasn't obvious at all initially. I found the solution by reading a forum post where someone had the same issue creating a log rotating service. Now, another issue was the upload service. It kept failing instantly, going into a start limit error. Now, I checked the logs and saw the R clone exited immediately without uploading anything. At first, I thought I misconfigured the remote. But after adding debug flags, I saw messages about iNotify not being available. That's when I realized I forgot to install the package iNotify-tools, which Rclone relies on to detect file changes. Once I installed it, the upload service ran normally and began syncing videos to Google Drive. I also ran into a tricky hardware issue. When I started MJPG Streamer, the FFmpeg together, the webcam would turn on for a second and then shut off. I wasn't sure if the camera was defective or if my Pi couldn't power it. To debug this, I ran Fuser and LSOF on device/video0 and discovered that multiple processes were trying to access the camera at the same time. Webcams can only be opened by one program at a time, so Motion MJPG Streamer and FFmpeg were essentially competing for the device. This explained why I was seeing intermittent crashes and camera disconnects. I solved this by clearly separating the components. MJPG streamer handles the live streaming alone, and FFmpeg records from the stream, not directly from the camera. That removed the conflict entirely. Overall, troubleshooting these issues helped me significantly improve my debugging skills. I learned how to interpret system logs, analyze device permissions, trace conflicting processes, and understand how Linux systems interact with hardware. Even though the project took a lot longer because of these issues, the process taught me more about real-world systems engineering, and if everything had worked on then if everything had worked on the first try. Through this project, I learned how to automate services on Linux, work with device-level video interfaces, manage cloud uploads programmatically, and debug system services. This project really helped me understand how real surveillance systems work. Thank you for watching my Raspberry Pi security camera project. This system now streams live video, records continuously, and uploads recordings on Google Drive automatically. It was a challenging project, but I learned a lot and I'm proud of the final result. Thank you.